Welcome. In this video, I'm going to go over how to find the limit as x approaches infinity and the limit as x approaches negative infinity of this function here, g of x, defined as 1 divided by x. Then we're going to discuss what this result may suggest for the limit of a constant over x as x approaches infinity, or a constant over x as x approaches negative infinity. So let's begin by sketching a graph. So looking at this graph, so here in blue I have the graph of y equals g of x, which is defined as 1 over x. And using this graph, we're going to evaluate these two limits. So the limit of 1 over x as x approaches infinity, that is, x goes out forever, what is happening to this graph? Since I can't zoom in on my hand sketch, here's the same sketch using GeoGebra. And so let's just move along the x-axis. And as we get larger and larger, that is, as x gets larger and larger, it looks like this graph is becoming the x-axis. But let's double check that that is the case. And now here we are. We have larger values of x and smaller values of y. So no matter how large we get on x, it's clear that this blue graph, that is g of x, will never touch the x-axis. It's just going to get closer and closer and closer to the x-axis without actually ever touching the x-axis. So as x approaches infinity, this function is going to approach 0. Now let's do the same thing for negative infinity. Here's just a standard graph of g of x, not zoomed in at all. And now I'm going to move along the negative x-axis. So I want to make my numbers along the x-axis more and more negative. And then along the y-axis, I'm going to zoom out to get closer and closer to 0. And what we can see is the same thing is happening. Our values of x are getting more and more negative. But this blue graph still does not touch the x-axis. It remains right below. This tells me that the limit as x approaches infinity, not infinity, negative infinity of 1 over x is also equal to 0. Now to answer the other part of this question, what does our result suggest for the limit as x approaches infinity of a over x and the limit as x approaches negative infinity of b over x, where both a and b are real numbers? I can use the limit laws to rewrite this as a times the limit as x approaches infinity of 1 over x. I know that this limit here is 0. So this is just a times 0, which is 0. Similarly, I can rewrite the second limit as b times the limit as x approaches negative infinity of 1 over x, which is, again, this limit here is just equal to 0. So this is b times 0, which is 0. So these limits suggest that if we multiply by a constant out front, so any constant, so I could have, say, 2 over x, or 10 over x, or 1,000 over x, pi, even pi over x, anything we multiply, we're still, as we go out to infinity, our function will approach the x-axis. That is, it approaches the line y equals 0, but it will never cross it. So in general, since these limits are equal to 0, we know that the line y equals 0 is a horizontal asymptote of g of x equals 1 over x. Additionally, we know that multiplying g of x by any constant out front will not change this horizontal asymptote. I hope this video was helpful.